Welcome to this presentation on the DBR77 platform's product, the digital twin with algorithms. Another groundbreaking tool developed and implemented on the DBR77 platform is the digital twin of the manufacturing plant. This is a completely new concept for automating both operational consulting, which includes support at the process design level, and the automation of managerial decisions made daily on the production line. To the best of our knowledge, DBR77 is the only provider offering such an advanced environment of an entire manufacturing plant available in the cloud. The technology of digital twins is currently one of the fastest advancing trends in the digital transformation of the industry. Previously used mainly for three-dimensional designing of various details and finished products and for the graphical representation of individual machines, it is now gaining new applications. DBR77, adapting technologies previously used exclusively in the gaming world, has introduced a digital twin of comprehensive manufacturing plants or logistics centers to the market. This product represents a real breakthrough in the design of production lines and entire plants. In our understanding, a digital twin is a graphical and numerical representation of the real world in a virtual environment. It enables both the representation and analysis of physical distances between objects in 3 dimensions as well as the analysis of tasks and connections executed between various objects. The digital twin is used to properly utilize IoT data, such as the DBR77 Big Data, to manage data in real time, conduct simulations and processes, and enhance the efficiency and productivity of activities carried out in a manufacturing plant or logistics center environment. The digital twin of the manufacturing plant enables 4 key actions. The first is the visual organization of production line stations or the entire plant. In this variant, it is possible to design new manufacturing plants or redesign existing ones. In practice, our clients use visualization to reduce the number of decision-making errors when preparing new investments. Visualization is also often used for training and commercial processes. Simulation in the digital twin allows for a deep analysis of various decision-making scenarios. Through simulation, we can replicate very complex assumptions of the production environment. Variant simulations enable the use of predictive algorithms. In practice, these algorithms assist in managerial decisions made daily in the production and logistics environment. The most advanced use of the digital twin is creating data to train pre-trained algorithms. This class of algorithms represents the future of AI algorithm utilization in everyday life. The premise of the DBR77 strategy is to create solutions with a very low barrier to entry for clients. While our competitors' solutions require substantial investment in both hardware and software, our solution is available via a monthly cloud subscription. In practice, the cost of accessing the digital twin environment is negligible from the perspective of the benefits derived from its use. Equally important, the knowledge barrier to utilizing the environment is also very low. For this purpose, the digital twin environment is based on programming typical for the gaming world. The way of working in the environment is similar to well-known games such as The Sims. Practically anyone can start independent project work in the 3D DBR77 Virtual Studio after just an hour of training. Digital twins open new perspectives for design and prototyping in the industry, allowing for simulations and improving the efficiency of production stations and entire production lines in the warehouse and logistics environment, optimal utilization of human resources, and ultimately enhancing the efficiency of the entire manufacturing plant. Minimizing design errors, improving process efficiency, and safety in the designed area are just the beginning of their capabilities. This functionality also revolutionizes training, moving employees to an interactive virtual environment, which increases the effectiveness of learning. Additionally, realistic presentations of products and solutions in 3D, as well as their visualization in VR, virtual reality, and AR, augmented reality, open a new dimension of interaction with clients and within the organization. Creating a digital twin begins with generating a new spatial environment for the plant. It starts with a precise mapping of the layout, which forms the basis for placing all 3D objects in the virtual hall. Next, animations are designed to simulate interactions between objects, enhancing the understanding of workflow and potential interventions. An important stage is also defining specific parameters for each element and action that will play a role in production scenarios. After launching, there is an iterative process of refining animations to best reflect the operational reality. The final step is exporting the finished animations and reports, which can be used for process analysis, project presentations, or training. Another functionality of the digital twin is simulation. In this area, DBR77 has classified elements of the production hall into 8 categories, defining specific data ranges necessary for conducting a comprehensive simulation of the plant's operation. These categories include production stations, storage areas, operators, industrial robots, transport vehicles, production components, packaging, and sensors. This segmentation and detailed data specification enable the creation of realistic scenarios of the plant's operation, allowing for precise prediction and optimization of production and logistics processes. The DBR77 digital twin and its simulation version opens new possibilities for operational analytics, enabling rapid analysis of even the most complex issues. Thanks to the value stream mapping, VSM, for production series, companies can accurately track and improve each step in the supply chain. Production and logistics processes undergo continuous optimization, and precise forecasting of resource requirements ensures operational fluidity. This tool also offers a detailed performance analysis under various organizational configurations and allows for scenario analysis, which is crucial for identifying and managing critical events in the organization. Creating a digital twin involves a series of coordinated steps that begin with setting up the plant in a visual environment. This setup includes both the architecture of the plant and the placement of individual elements that reflect the real flow of materials on production lines. The next step is the introduction of basic data, such as machine parameters, cycle times, and available resources. After entering basic data, the stage of introducing data specific for simulations follows, including daily production plans. The simulation allows for testing and verifying plans and identifying potential problems before they occur in real conditions. The final step is downloading reports from the simulation, which provide detailed information about the results and allow for further analysis and optimization of processes. The DBR77 platform provides a set of 6 key predictive algorithms that revolutionize planning and execution in the facility. Among them is a scheduling algorithm that streamlines the queuing of orders for production and in storage, increasing resource utilization efficiency. The Master Production Schedule, MPS, allows for detailed production planning in line with current demand and material availability. The line balancing algorithm ensures optimal distribution of workloads, which translates into efficiency and reduced production time. The VSM variant analysis identifies the most efficient value flow paths, while optimizing intra-logistic flow and material allocation in the warehouse are steps towards minimizing the time and costs associated with internal logistics of the facility. In the function of creating predictive algorithms, the DBR77 digital twin becomes an invaluable tool that enables automatic and rapid scenario analysis, which is crucial for the real-time decision-making process. By utilizing algorithms based on a wide spectrum of data and assumptions, the system allows for generating advanced predictions and recommendations, which are refined and adjusted over time as conditions change. Simulation results can be automatically used for further work, increasing the speed and efficiency of processes. Moreover, the use of such algorithms minimizes the risk of human errors, ensuring more objective and reliable decision-making. The process of creating a digital twin begins with configuring a virtual model of the facility that replicates its actual layout, similar to creating visualizations. Then, operational data necessary for simulation, including both constant and variable process parameters, are introduced into this environment. Setting variable parameters allows for modeling different operational scenarios in response to changing conditions. The next stage involves conducting simulations with automatically changing assumptions, which enables dynamizing the process and adapting it to potential fluctuations in input data. It is also important to create a database of results, which serves as a repository of collected information and analyzes. The final step is the selection of the optimal solution based on simulation data, allowing for choosing the most effective and current needs-aligned direction of action for the facility. Pre-trained algorithms in the DBR77 digital twin serve as powerful tools for rapid response in dynamic production environments. Thanks to previously gathered and analyzed data, it is possible to make immediate decisions in cases such as a failure at a production station, the need to change shipping plans, material shortages, delivery delays, or the detection of quality defects. These algorithms also allow for effective management of unexpected staff shortages. The application of such solutions significantly increases the flexibility and adaptability of production processes, minimizing downtime and optimizing workflow even in the most unexpected circumstances. The DBR77 digital twin offers advanced features for digital twin (DT) algorithms that significantly improve the management of production processes. One of the key capabilities is the immediate resolution of problems based on predefined conditions, which allows for swift response in emergency situations without the need for manual analysis. Additionally, this system automatically creates a database that is used for teaching and continuous refinement of algorithms, enhancing their effectiveness and accuracy in decision-making. The self-improving algorithm continually learns from each new situation, ensuring increasingly better adaptation to the specifics of the production organization. Creating a digital twin begins with precisely setting up the facility in a virtual environment, analogous to preparing a set for visualization. The next step is the introduction of data that will form the basis for simulating production processes, such as raw materials, machine cycle times, or staff availability. Next, variable parameters must be set in the simulation, which may pertain to varying working conditions or potential equipment failures. The simulation process itself includes automatic variability of assumptions, allowing for the modeling of different scenarios and their impact on production processes. This simulation also allows for the generation and accumulation of data in a database, which serves as the basis for analyses and reports. The final step is training algorithms, which, thanks to the collected information, can better predict the future needs of the facility and assist in decision-making. The implementation of the digital twin brings significant benefits to organizations, especially in the first year of use. There is an observed average increase of 20% in efficiency in production and logistics areas, resulting from process improvements and workflow optimization. The benefits related to management and the decision-making process are also significant, with a reduction in the time needed for managerial decision-making reaching up to 97%. It's difficult to estimate how many incorrect decisions have been avoided thanks to this technology, but experience shows that companies that have started using the digital twin can no longer imagine returning to old working methods. I warmly invite you to visit www.dbr77.com, where we have gathered an extensive knowledge base on the digital transformation processes in manufacturing enterprises. On our platform, you will find comprehensive information about key aspects of digitization, as well as detailed descriptions of all our products. I hope this information will convince you to further explore the opportunities offered by the DBR77 platform and encourage you to contact us. Thank you for your time, and we look forward to talking with you.